Hi, in this demo I will show you how to create AI models and make predictions. I will use the Practicus AI app and the Cloud Node for most of the features. And I will also show how to use Excel to make predictions. We will use the diamond dataset. This is a famous problem, and it is about predicting diamond prices. Cut, clarity, and other features about a diamond create roughly 7,000 combinations. When you add carat weight, we will have several million possible combinations. Our dataset only has 6,000 rows, not millions, so we wouldn't be able to simply look up the price of any diamond. Normally, an expert opinion, a jeweler, is needed to accurately value a diamond. In our case, we will use AI to make such a prediction with the limited data we have. I will click Model and choose what we want to predict, which is price. There are several other things you can do on this dialog using the Advanced section. We will cover some of these later. I will click OK to build the model. Depending on the data complexity and how much cloud capacity you have, this can take anywhere between a few minutes to a few hours. Our model is built. At the top, we will see the average amount of error we estimate this model will make if it is used with data that we have never seen before. There are multiple options on this screen. You don't need to, but I will choose all of them and explain what each are in a minute. Some of these options will be very useful, especially for technical users. We built two models by default. The first one is saved in an Excel file, and it is easier to share with others. And the other one is a full-fledged model where you need to use our app or some other program to make predictions. We can start making predictions by entering data in Excel. For the sake of simplicity, I will use data from the app. The AI model made a prediction without polish and symmetry. This might not be the case for other values. For instance, a larger carat weight might use these features. What if I enter a carat weight that the AI model has never seen, such as 3? The model will predict 25,000, but will also give a warning since this is outside of the training range. And we warn for categorical features as well. This can be handy if you copy-paste data between systems. Let me do that. Predictions are made. Now I can copy them and paste it back at the application. In case you are curious, you can also view how the predictions are made. In this case, this is a decision tree model. You can also view and change how the value warnings are generated. If a user has Practicus AI app installed, predicting with the app will allow us to use advanced AI models, search for them, use any AI model built on any system, and many more features. I will now predict using the full-fledged model. Let me click Predict. There are multiple places we can locate an AI model. In this demo, I will use MLflow. By default, we register AI models into a local MLflow database after modeling. You can change the default to a central database in the cloud so different users can collaborate and use each other's models. If you know the address of the model, you can type it or click the 3 dots to search for the model as well. I found the model and there's only one version. In a production setting, there could be multiple versions, and in that case, I could pick a version that is marked as production quality. I can click OK now to make the prediction. By clicking Load, we can learn more about this model as well. In this screen, you can view the features that the model needs and the features that we assign. We use an AI algorithm to match the field names even if they are not the same. Clicking Open Model Worksheet shows us the entire history of the AI model building exercise. This is called data lineage, and it can be crucial for several reasons, including compliance requirements. Now let's make the prediction. As you can see, the full-fledged model predictions were more precise. Let's say you deal with a complex problem and the AI model has some room for improvement. A logical next step would be to take a closer look at the current model experiment details. In this page, you can view information such as model parameters, some of the success criteria beyond error, and other important information. We also built a Jupyter notebook so you or a data scientist can customize the model without starting from scratch. Let's say you have an amazing data science team and they built a great AI model with or without coding. If the data used is not good enough, the predictions made will not be good enough either. This is often called garbage in, garbage out problem, or simply GIGO. When you deal with a complex problem, it is possible that a complex solution, potentially with coding, might not be the answer. Sometimes all you need is finding ways to prepare better data. And this is exactly what we will discuss in the next video.